AUTOSAR. Explained by Annette Kempf.
Hello, thank you for joining again on an AUTOSAR session. Today we are going to have a look at the crypto drivers. But before we are going into detail, we'll have introduction from an overall perspective. So first we start to look into AUTOSAR Classic in general, and then we will have a look at the microcontroller abstraction layer as an overall explanation. And this information will be derived from the existing Embedded Academy e-learning on AUTOSAR. And once we have this introduction, we will have a look at the crypto drivers directly, which will be done by me. So first of all, have a look at the e-learning, and I will be right back with you afterwards. See you.
The Classic Platform is AUTOSAR's solution for embedded systems with hard real-time and safety constraints. The architecture distinguishes on the highest abstraction level between three software layers which run on a microcontroller. The lowest layer is the basic software layer. It is divided into three major layers and complex drivers. The Microcontroller Abstraction Layer is the lowest software layer of the basic software. It contains internal drivers, which are software modules with direct access to peripherals. The main task of this layer is to make higher software layers independent of microcontrollers. The ECU abstraction layer connects the drivers of the microcontroller abstraction layer. It also contains drivers for external devices. It offers an application interface for access to peripherals and devices regardless of their location and their connection to the microcontroller. The main task of this layer is to make higher software layers independent of the ECU hardware layout. The complex drivers layer spans from the hardware to the runtime environment. Its main task is to provide the possibility to integrate special-purpose functionality. The services layer is the highest layer of the basic software, which also applies for its relevance for the application software. It offers, for example, diagnostic services and memory services. Its main task is to provide basic services for applications, runtime environment and basic software modules. Above the basic software lays the runtime environment. This layer provides communication services to the application software. The AUTOSAR software components communicate with other components and services via the runtime environment. The main task of this layer is to make the AUTOSAR software components independent from the mapping to a specific ECU. The application software layer realizes the application functionality. This layer is mostly hardware independent and consists of different software components. The microcontroller abstraction layer is divided into 6 model groups, which group software modules of similar type. In this case, the software modules are internal drivers. A driver is a software module with direct access to peripherals. The internal peripheral devices are shown in the hardware layer. The module group microcontroller drivers consists of drivers for internal peripherals, like the general-purpose timer and the watchdog, as well as functions with direct microcontroller access, like the core test. The module group memory drivers consists of drivers for memory-mapped external memory devices, like the external flash, and on-chip memory devices, like the internal flash and the internal EEPROM. The crypto drivers are drivers for on-chip crypto devices like SHI or HSM.
Okay, now we're back. So we will have a look, first of all, at the AUTOSAR web page. So we are here under standards. A classic platform is chosen, and as you saw the introduction, it's the same colors like the microcontroller level and here the microcontroller abstraction level. And we are going to have a look at the crypto drivers. Yeah, I already opened the window. There is not a lot of specifications and documentation inside. And in fact, I believe that specification of a key manager should be not in the microcontroller abstraction layer, because it's more services oriented, but we will have a look into it nevertheless, so that you get the next level of orientation. And then we'll have a look at the requirements on the crypto stack. Yeah. So first, this here, it's the key manager. And what I wanted to show you in this key manager specification, you see the key manager in this picture is indicated here, part of a services layer. So here you have a microcontroller abstraction layer. And then you have a different layers, yeah. And the key manager is part of the services, but what's a very nice picture is to see the different elements and where you find what, yeah. Here you have first of all the hardware security module and the security hardware extensions. So there you have some security features within the microcontroller itself, yeah. And here on the other hand, it's SPI communication, which is indicated because you need also often some communication. For this part, just to have some remarks on the hardware security module. I remember when I was in projects where they first started with a hardware security module, we had lots of issues also in handling the things during development. So it's not so easy to handle this hardware. Secure is important, but the question is on how to work with it during development. Just a remark. So I would say that you need to set up also a process around this, and to see how people can work with projects where they have these crypto-related hardware modules to handle also within the organization, who might not have anything to do with crypto services. They just simply want to do their, I don't know, control algorithm for something, yeah, and to test at the test bench. So there is more to this than implementing it. It's also the processes around and how to handle it. And I think then this here is giving a very good picture. But currently we're only looking at the crypto drivers, yeah. And there we first will have a look at the requirements specification. Many people who are experienced in, I already scrolled down a little bit to the scope of the document. Many people who are experienced with embedded software development and have been working for many years have not had any contact with cryptography before. And then you're talking about all these cryptography terms you might need. But first of all, here, the scope of the document. This scope of the document is a little bit more than you might expect it. It's the crypto service manager, CSM, the crypto interface, and the crypto driver, and the key manager. And then here also in the abbreviation list, you already see some terms you might not know, yeah, which then is more difficult to understand if you don't have the cryptography basics or background. And I would really highly recommend to get this know-how, because there are different encryption standards, and here advanced encryption standard is mentioned. Then you have cipher abbreviations, which might not be in general terms, but more in this context. You have different authentication codes, yeah, if it's hash-based or others. You have cryptography in different areas. For example, you also have Diffie-Hellman mentioned here. And what I would like to have a look at first is to have a look at the Embedded Academy e-learning on cryptography. So we have a course on cryptography, which is providing quite a lot of content and a general understanding of all the things you find in there. So we're starting with the basics. And basics also includes to understand the different players and to see an example. Then it's some older, easy to understand cryptography, encryption and decryption methods. Yeah. And this is also some classical things like the one-time pad and Enigma. And then we are going towards modern cryptography, providing information on these protagonists, Alice and Bob, and also the ones which, for example, hacking. Then it's important to distinguish between symmetric encryption and asymmetric encryption. There are also hybrid encryption methods. Yeah, and then you will learn about the modern encryption methods. So we already saw advanced encryption standard AES, but there's also DES explained. And here, like we saw before, Diffie-Hellman key exchange, and there's also RSA. Yeah. Overall, I think here we have a little, no, it's the same content description as it's there. Altogether, this training is lasting 4 hours just to click through. So it will take you around 2 days to learn about cryptography in general, to get to know all the terms. And I would really recommend to start with this before even to read the specification, because you will need to have an understanding on all the terms first. Yeah. In the requirements, then we find lots of these terms which we saw here. Yeah. And there are some algorithms which are supported by the driver. It doesn't necessarily mean that you are using this algorithm, but the ones should be implemented and are available. So it's like deterministic random number generator and true random number generator. For here, we are looking at symmetric encryption, where the encryption and the decryption key are the same. It's advanced encryption standard, yeah, with different key lengths and with different modes, and further, yeah. So you will need to know about all these different standards and to understand also the different modes to be able to select the right one and to communicate and to understand what you're doing there. So, for example, the hash, the MAC, the key exchange. So this is all connected to cryptography. So you really need to understand first before understanding the requirements. Now we have a look at the specification. In the specification, it's the same structure as always. The introduction and functional overview, acronyms and abbreviation, the related documentation, constraints and assumptions, the dependencies to other modules, the requirements tracing, and then it's here the functional description. So the configuration, the capabilities, the available keys, which keys do you have, yeah? The general behavior, the functional requirement, do you have synchronous job processing or asynchronous job processing, some design notes, the key management, how do you have the key is essential, yeah, for encryption and decryption. Then the key formats, so which keys do you have? Is it RSA, ECC, or SHE, yeah? How do you store the key in your non-volatile data memory, and the crypto profiles. Yeah? And of course, nobody can take you through everything, but I think to handle this, first of all, you need to understand the full picture. I think it's not enough to look just at the driver, and you need to understand cryptography. So I would like to go back to this picture. So to handle this driver, you need to understand what the hardware is doing, how it's interacting, how it's done for this microcontroller, and then you can handle the drivers. But like most of MCAL drivers, this usually is part of a MCAL driver package, which is provided by the chip producers. And then I will now have a look at the pictures, what they are showing from a chip producer side. So here it's a picture from an NXP microcontroller. And you see here that they did not give the details on the microcontroller, but they have a crypto drivers, and it's an NXP standard product. So it's part of their delivery, and you can trust that it fits together, the microcontroller and the crypto driver. And I think this is very important. And so in green is what NXP is providing, and in blue is what they are providing via partners. Yeah. Another example is for Infineon. For Infineon, I just chose the Aurix TC2 and TC3. For newer microcontrollers, it might be different. You always have to check. Yeah. And here you have, on the one hand, the MCAL drivers, which are provided from Infineon. Here, crypto is not part of it. It's enabled via partners. So you have to see where you get it from and how it is working for your special microcontroller, to get the overall picture. But usually what you do is it's this in between the very technical things are usually provided by very experienced people, and what you have to do is all the certificate handling, key handling, saving this, and on the other hand, ensuring that your development team can still work during the development of your product, so that they are not hampered by these security features. I would stop here and going into more detail. I think you can look also in the specification, but as I said, I would highly recommend to get some training on cryptography beforehand to have a deep know-how in which direction towards what you are heading. Thank you for joining today. Next topic will come in a few weeks. Thank you and bye-bye.
If you want to learn more about AUTOSAR and other interesting topics, go to embedded-academy.com.